Hey guys, this is question MM003 in the Maths Methods Sharpen Study Guide. How to solve a system of linear equations, simultaneous linear equations for a value of m when there are no solutions. So this can kind of look a little bit confusing to start with, but if you look at the cheat sheet section of the Sharpen book, you'll be able to see a detailed run through, and I'll do a video on a general solution for this sort of stuff as well. But basically the first thing we need to do is firstly write down these equations. So we've got 4x plus my equals 3m, and equation 2 is mx plus 16y equals 32. Now, if this sort of question confuses you, just think of these two linear equations as two linear graphs on the same axis. So if you can imagine, we've got just an axis, obviously y and x, and we have two linear equations on this graph. Now, no solutions. If you think of a solution as a point of intersection between those two graphs, and these two graphs have no solutions or no points of intersection, then that means that these graphs have to be parallel, because that's the only way that they're never going to cross each other. So the only way that this happens is if their gradients are both the same, but their y-intercepts are different. If they have the same gradient and the same y-intercept, they would be the same graph, and they would have infinitely many solutions or infinitely many points of intersection. So when they have no solutions, their gradients equal each other and their y-intercepts do not equal each other. How do we figure that out? Firstly, we need to actually get it into the form y equals mx plus c. So let's start with our first one. I like to rewrite it, just makes it a little bit cleaner for me. Like I said, we need to get it in form y equals mx plus c, so we rearrange that so that we can get it in the form y equals something. So my equals negative 4x plus 3m, which gives y equals negative 4 over mx plus 3m over m, which of course equals negative 4 over mx plus 3. M's cancel out. Our second equation is equal to mx plus 16y equals 32, which means that 16y equals negative mx plus 32, and of course y equals negative m on 16x plus 2, which is 32 divided by 16. Now that we've got our equations in the form y equals mx plus c, we can actually compare them, because when we've got it in these two forms, it's very, very difficult to compare. It's like comparing apples and oranges. They're not the same thing, whereas when they're in this form here, y equals mx plus c, they're very, very easy to compare. So the first thing we need to do, we know that the gradients are the same, which means that we need to equate these two gradients to each other. So the first thing we do is we take the first gradient, which is negative 4 over m, and the second gradient, which is negative m on 16. And then we just solve for m. So from here we know that negative 4 times 16 equals negative m times m. I've just cross multiplied there. Negative 4 times 16 is negative 64, and negative m times m is negative m squared. Now the negatives can cancel each other, which means that m squared equals 64, which then means that m equals plus minus the square root of 64, which is plus minus 8. So we know that when m equals 8 and negative 8, the gradients are the same. Now, we don't know if the gradients will produce a different or same y-intercept, usually. Usually there's an m on the end here, but because this is 3 and this is 2, these two y-intercepts can never be the same regardless of what m is, because m only affects the gradient. So that means that for these two values of m, there are no solutions because the graphs are parallel. There's no points of intersection. So our answer is A, which is m is negative 8 and positive 8. So that's how you work that one out.